So,
Can I start?
yeah, you can start now.
Our title is The Behavior of Concrete Filled Single and Double Skin uPVC Tubular Columns Reinforced with BRC Mesh in Compression. The presenters are myself, Keith Kagiri, and my partner, Jude Kimolo Kingo. And we're being supervised by Dr. Naftali Gadimba. So these are the contents of our presentation. We'll start with the background information. So concrete confinement has significantly improved the structural performance of members, structural members, especially columns. Concrete filled steel tube columns have been used for the construction of high-rise buildings, and we've also seen the emergence of other materials such as FRP, uPVC, and PVC due to the high cost and corrosion of steel. These are the recent studies have been done on the use of uPVC as a confining medium in single and double skin tubes by the researchers Abraham and Walter Oyawa and Timothy Nyamboi. And then double skin concrete filled tubular columns have proven to be lighter and have better fire resistance and higher ductility than the single skin tubes. So the problem statement that we're addressing is previous researchers experienced the stated failures, which is drum type, shear failure, and bursting. So we are addressing this by reinforcing the tubes with BRC mesh.
In our problem justification, we saw that there is need to develop and enhance the strength of the tubes to reduce on the problems that the previous researchers encountered. At the moment, construction projects are in an all-time high. Hence, this is geared to finding new ways of construction that are cost-effective. In addition to that, we've been experiencing a global problem of environmental pollution by plastics, and this will trigger that. This will ensure that we reduce on the pollution of plastics when this could be put to use. Our overall objective is to determine the behavior of confined concrete in compression. Our specific objectives include to investigate the effect of BRC mesh reinforcement on confined concrete in compression, and to compare the strength of confined and unconfined concrete tubular columns reinforced with BRC mesh in compression. The scope of study, it will involve carrying out compression tests on both single and double skin confined concrete in uPVC tubes reinforced with BRC mesh. The limitation that we've encountered is that we have insufficient resources to carry out more and more tests on the topic.
So on the literature review, these are the three main researches that we have looked at that have been done previously. And one of them, the first one is from the author Abraham and Walter Oyawa. And the findings was there was a significant increase in strength and energy absorption and ductility. The title was, sorry, I think we put that, the title should have come first before the finding. So the title is, the title was The Behavior of Concrete Filled Single and Double Skin uPVC Tubular Columns Under Actual Compression Loads. And their finding was a significant increase in strength and energy absorption and ductility. The next researcher was Gupta in 2013. He did confinement of concrete columns with unplasticized polyvinyl chloride tubes, and his finding was an increase in strength and ductility. The third researcher was in 2015, which was Walter Oyawa and Naftali Gadimba, and their title was Innovative Composite Concrete Filled Plastic Tubes in Compression. And the finding was there was an increase in strength, 1.85 to 3.65 times the unconfined strength values. The critique in all these researches is we believe that they experience failures due to lack of reinforcement. So that is the difference in our research. So the research gap, we found that the previous researchers did not reinforce the specimens. So we have reinforced ours with the BRC mesh. So in the research methodology, the materials that we required were fine and coarse aggregate. We used the cement of class 42.5, uPVC tubes, BRC mesh, and water. So this is the research flow. We started with the sampling of fine and coarse aggregates, doing the tests on them, which include specific gravity, sieve analysis, water absorption, and so on. So after that, we prepared a concrete mix, which included we did 5 cubes of 150 by 150. And we also prepared, we did a slump test. And we also, after that, now we went into casting of the cubes and also casting of the concrete, of the uPVC tubes. As you can see in the next slide here, this is a photo of Jude preparing the molds for the cubes. And in the next photo, we can see the cubes have been casted together with the uPVC columns. So this is the sketch of the cross section of the tubes, and the dotted line represents the BRC mesh, and the other full line represents the plastic. So this is just a picture of the compressing machine in the lab that we use to compress the columns.
Well, in our results, we started with the sieve analysis of the fine aggregate. This was done in accordance to BS 882/1992. We used 500 grams of river sand for the analysis. The sieve sizes we used were 10, 5, 1.25, 0.6, 0.3, and 0.18 millimeters. In our next slide, you can see that there's a graph. This is the results. The blue line is are the results of the fine aggregate when we are sieving, and as you can see, it fits in the envelope that is acceptable in accordance to British standards. Proper fine aggregate during construction should be within that envelope, as you can see from that graph. In our coarse aggregate, we tested for specific gravity, water absorption, and the aggregate crushing value. The specific gravity we found was to be 2.74, making it suitable since it's within the recommended bracket of 2.5 to 3.0 as indicated in British standards 812/1995. The water absorption was found to be 7.4%, which is higher than the recommended value of 3% according to BS 6349, making it appropriate for use. The aggregate crushing value was we calculated and found to be 24.74%, which is below the maximum acceptable value of 30%. Hence, the aggregate was okay in aggregate crushing value in accordance with BS 812/110/1990.
So this is the work plan and what we have been able to do so far. So by the end of this month, we'll be able to compress the uPVC columns. And these are some of our references. And that's the end of our presentation. Thank you.
All right. Can you go back to your main to your title? You see, it's about the behavior of concrete field. This single and double skin uPVC, is it?
Yes.
But in your methodology, have I seen the photos that you are showing? Have you done for single?
Yes, you have.
Yes.
You showed the photos?
Yes.
Oh, because the aspect is to see the improvement that can be achieved by using double skin. I think you need to do a little bit more of reading, because the problem, I mean, in terms of the need for your research is not very clear. Because if you move to slide, can you go to introduction? We need to know why do you have to use the PRC mesh? Okay. Introduction. Then next slide. The introduction, basically, there's something you are saying. Next slide. There's somewhere you are saying that the failure is occurring. And by the way, if you're going to present online, I would advise you to avoid using too much of animation, especially when transitioning from one slide to the other. What do you call that? Is that animation?
Yes.
Transitions. Yeah, transition, not animation, transitions. Because sometimes, because of the lag in the internet, you find like a bit distracting before you can move to the next slide. When you're physical, when you're presenting in a physical audience, I think it's easy because you're just projecting without using the internet. Now, on these, whatever you have been saying is the issue. You're talking of, I wanted the slide where there is a failure. I think it's the next slide, number 5, if I'm not wrong. 5, then 6. Okay, this one. Both 4 and 5. Number 4 and 5. You see, you're saying these are the failure modes experienced by free researchers, right? And my issue, my question is, what is the preferred mode of failure? I mean, you are saying you want to use the BRC mesh because you think that whatever is experienced from the previous researchers is kind of a shortcoming, is it?
Yeah.
Yeah, but then at one point we know that we are not going to make an infinitely strong column, like a column that will never fail. So the question remains, why do you think that you need to bring the BRC mesh? Because your statement, it's just a matter of the way you are stating it. Because your statement, you are saying that all these are the failure. And now it's like you are bringing the BRC mesh to avoid failure. But we know at the end of the testing, because we are limited, we are in a real world. We are not going to construct to come up with a column system which will never fail. Okay. So the question should be more concerned, because when you are saying this, and I also found it in your literature review. I believe in the literature review, what you are calling critique is not a critique, because you are saying no reinforcement was used, but the critique is from their research. What is that shortcoming? I mean, remember what you're doing here, just to give you a hint, is just improvement. You want to improve. Okay? So if the failure, what we could say, if there was premature failure that was occurring through the bursting of the pipe, okay, we are trying to see whether the BRC mesh can bring and enhance more confinement. Remember, you're also looking at the cost. Okay, so in the literature review slide, I don't know which slide is that. In that slide where you are saying no reinforcement was used, I mean, unless you tell us why do you think the reinforcement would have done to this experiment that they did? Because if we do not use the reinforcement and we can attain to a certain design spring, yeah, we are far much better than when you use the reinforcement, because we are saving on cost. Remember, reinforcement that you are using, you're proposing, which is BRC, is steel. And in steel, in the introduction, you are raising the issue of the shortcomings of steel, cost and corrosion. So if there be any ingress of moisture in the column, then the corrosion may come back into play. So much more, I just want to challenge you to read. I want to challenge you to do a good literature review so that you can understand exactly what are you trying to do when you are bringing in the mesh. Remember, the mesh, we do not anticipate it to provide any axial load capacity enhancement. I mean, the mesh itself, we do not expect it to carry external. It's about the confinement effect. Confining, I mean, confining is like containing the concrete. That's what the uPVC pipe is doing. So you see, the uPVC pipe in itself, if you try to test it at the axial loading, we do not anticipate much strength gain, but because of the lateral pressure that it applies to concrete, that's why now our concrete, we delay the failure of the concrete itself occurring because it has been confined. There is lateral confinement, and that's the role that the mesh is coming to add or to complement to the plastic tube. So think about that. I'm still feeling to a person who have never seen this kind of research or who have never been in this field, the way you are explaining, the reason why you are using the mesh is not coming out clear. And even this literature review is not helpful. This, whatever you're talking, the critic, they should be in the literature, in the gap, research gap, the summary, the next slide that you are saying. So the gap could be from you're saying the previous guy did not reinforce the specimen, but we need to know why the reinforcement, because they did not use the reinforcement of the mesh. What was it that research did not achieve? And I'm challenging you to go to those papers because they have graphs. Yeah, look at the failure. Look at the loading history. Look at the like, for example, force displacement curves. Because the aspect, whatever we are trying to enhance here, I can give you a hint, is more of the ductility. That is the post-yielding behavior. Yeah. And also, I believe even the stiffness, even pre-yielding behavior, the stiffness may be enhanced. Okay, those are the things that we are trying to improve on. Whether it can be able to sustain more load for a longer period without reaching the ultimate capacity. You get me? Yes. And make sure of make use of those, the literature review that you're doing, especially the introduction part. Make use of the graphs, because the graphs, I believe in some of these papers, you can be able to see the load deformation curve, or even the stress strain curve if you are using the strain gauges. But I prefer the load derogation because that's the only thing that you are able to see. You are able to do in the lab because you don't have the strain gauges. So that we can be able to see the stiffness when there is no confinement, the stiffness and the ductility, the stiffness and the post-yielding up to ultimate, up to maximum load. Maybe we want to see the behavior when it was unconfined. That is unconfined, the normal. I know the other researchers did that, and you're also going to do it because you're going to see the improvement. Yielding, this will be on the stiffness, and the post-yielding, that will be on the ductility. That how much elongation or deformation can occur before we attain the maximum load. Because now we'll be able to understand in case of like during low cycle fatigue, yeah, like earthquake, yeah, that goes beyond the elastic limit. How much load can it sustain before our column collapses? That is the gist of your research. Your research, if there be any capacity improvement in terms of the load capacity improvement, that will be an additional. But the purpose of this confinement that per se you're doing is more of the improvement in ductility. And I hope by now you should have known what are these terms that I'm using. Ductility, the stiffness, the post-yielding behavior. Okay? Yeah. So you need to once you review the literature, the references that you are using, and if in fact I don't even want you to go too much of a detail. Look at the work by Professor Ayawa. Look at the work by the latest one by Abraham, the first one. Look at the first one because this is 2019, and I believe he has another paper in 2020. Okay, look at that one. Look even at Gupta 2013. Try to see. Because what will make your research interesting to somebody else, to a new reader, somebody who is who doesn't know about this. Yeah, it's about whatever increment or whatever improvement you are suggesting. How is it? I mean, understanding how is your work adding or improving on the existing system. I remember this work in 2019 was done by somebody doing his PhD. Okay, so that's why I'm saying you don't even need to do much. At undergraduate, you are not expecting much from more than this. But we want first of all you to understand what he was doing. His recommendation, if you can get this is in the library, if not from his papers. What are the recommendation? Because I believe he suggested something that could be done. And that's why now you see people now start doing this thing of double skin because they saw an improvement using single skin. Now whether you can see more improvement, okay? So that your gap will not be the issue of failure, like the other Korans failed, we want to use the reinforcement. It's like that statement means you are saying once you use the reinforcement, now your Quran will not fail. You get me?
Yes.
Which is not true. Your Quran will fail. Of course, we expect it to fail. Anyway, this is a real one. If you are testing virtually, like in Abacus, and then you are just considering the an elastic material, then it might never fail. Okay. Yeah, so do a review and let your problem come out clearly. Whatever you are calling critique, this is not, remove that. No reinforcement. We want to see, you say Abraham did this. This is a research, the behavior concrete, in field, single and double skin. A significant increase in strength, energy absorption, and ductility. What was the shortcoming? Maybe the plastic pipe failed before ABCD, and you feel like improving on this. So you say this is the failure. There was the failure in this. I'm not saying you cannot not say the reinforcement, but I'm saying if you just say this is a critique, just no reinforcement, no reinforcement, no reinforcement. Somebody will wonder then why, what is the purpose of the reinforcement that this research did not achieve? I don't want to confuse you, but again, I want to open your mind. But what I'm telling you to do is to read those papers, read and understand this. At least these three researches, read and understand them, so that you really understand what your research is all about, and especially the first one. Okay.
Okay.
Then today I wanted much to concentrate on the progress. On the material, slide number 13. Yeah, slide number 13. Remember, your work is not materials. This is 12. 13, I think, is where you had the, yeah. I'm seeing in this research flow, I'm seeing too much of the testing, the material test, and even the result that you discussed, they are not bad. But remember, your work, you are in the structure. You know there is the people who are dealing with the materials. Maybe they want to see the improvement in concrete or in cement. Yeah, those are material tests. They might dwell so much and into details about the basic material test. But for your case, the test on the materials, the aggregates, if you have any test on the plastic, these tests are necessary for you for conformity purposes. Like you want to confirm whether the concrete was adequate. I mean, the aggregates are suitable for preparation for the concrete mix. But for you, that's not the area of concentration. Okay, so let's see more of the columns. Let's see more from the research flow, going all the way to the result, to the methodology, result, and discussion. Let's focus more on the columns because you are in the structural system, not on structural materials per se. Okay. So here I wanted to see the testing of the cubes. I mean, of the columns. I want to see the testing of the pipes themselves because you have not done any tests on the pipe. You need to see those tests. You need to conduct those tests on the pipes. Okay. Then, before you come to slide 14, or even after slide 14, I need to see what you call, this one you have not included. Show us the experimental setup. And this one, show a schematic representation. Don't show a photo. Any photo is good, but show us the arrangement because we want to see, and I believe either in one of these papers you might have seen these, they show the layout of the experiment. We want to see in this column, by now I should have seen what kind of data are you going to collect. So I want to see this schematic is like a sketch. You can sketch it in one. We see the load application. I want to see the data logger. The data you are going to correct the data is in data logger, is it? Is it? Because we want to see the load deformation curve. Because up to now, you are saying you are going to conduct the compression test. But if you just do the compression test, you're just going to get the ultimate strength. You're just going to get the load at failure, is it?
Yes.
But that's just one result. You just have one result. But we are saying the confinement does two things: improvement in stiffness and the improvement in load erogation. I mean, in ductility. That is post-yielding. It may sustain confinement helps to sustain load before reaching the ultimate capacity. Okay, yeah. So to be able to get the load erogation curves, we have to use. We do not have. For now, I don't want you to use the strain gauge because it's a process importing. But I want you to use what we call the linear variable displacement transducers. You know about them?
The linear
variable displacement transducers, LVDT. These are, and I know if now you have been visiting the lab, I believe there are people from PAU, the master student, who have been using that. Yeah. That is, you have the data logger. The data logger, you connect, LVDT are used to measure the erogation or the shortening or the lengthening or whatever, the deformation, change in length. Okay?
Yes.
You need to use that so that we can be able to get the loading as you load your column. The load, we are going to get the load deformation history. Okay.
Yes.
Yeah. So go and talk to Juma. I believe, and even you can talk to some students. Just go and watch. You know, the purpose why you are in the lab and there are other people there, other students, is this is the issue of the peer. You don't have to be to know the student who is doing the test. Once you see somebody using the data logger, just go talk to them and then see what they are doing with the data logger.
Okay.
Because that's why I'm saying you might end up, you are spending too much time on the material testing, which this should have been done within a span of 2 weeks or 1 week. Our focus is on the structural system, the column system. Okay. So the type of result that you'll be having, more of the discussion will be on the load deformation curves for the unconfined, for the single confinement, for the double ski, and double skin with mesh. So already you have kind of 4 sets of column of data. I mean, 4 sets of curves. It's kind of I'm giving you a guide. You have already 4 sets of curves, and it takes time to get this result, because like you are recording after every, let's say our data logger, the one that was there a long time ago, was manual. So you had to press after every to read after maybe every 2 seconds, and then it might take a long time. Maybe you test only 1 or 2 columns, because I believe there are other people there also doing that test, using that machine or the compression machine. So let's see the layout of your testing. Let's see the data, because from the layout, from the experimental setup, we are able to anticipate the result that we are going to get. That's what I expect to see today. So that if there is a shortcoming, if I see from your layout there is something that is missing, I could suggest some improvement. But for now, you see, I'm giving you the scratch. I'm telling you from the scratch because you don't have it. So yeah. Once you start doing it now, the shortcomings or the gaps that I would have pointed out today, I might not be able to point out today, because first I have to see you, to see your sketch. I have to see the layout. Okay. Even before you go to test, you have to see that layout. Okay, because you might end up spoiling your specimen. Good. Then the same case, just move to the other side so that you don't see like it. I'm talking about the research flow. So this is the match we are supposed to see here. The way you are saying the double skin, I like it. The way you are saying double skin, but we also need to see what is the length and what is the steadiness ratio. First of all, you have to be careful that you are using this. In fact, I don't think you will use this knee. this automatic one, compression machine. I believe the other one, which was manual, if it's still working, the one adjacent, the one that you're not showing completely, if it's still working, it had a good allowance for height. Okay, but if for this small one, I believe you'll be limited with the height. But anyway, that's not a big issue. For now, we are saying, for now we are inducing you. It's like an induction to test, to experimental test. This being a bachelor's research work. But again, we also need to see that you have learned something from the lab. Okay. Now, so also show us, we need to see like the test matrix. Test matrix is like a tabulation. You are showing us how many specimens, a table showing us for this type of a case, for the unconfined, I'm doing this test, having this height. So you have a table showing all those columns. Yeah. We are able to follow, we can be able to see from your progress, you have already done this specimen, this is what remaining. And that's where you're able to deduce that I've been able to attain this percentage of my work. Yeah, because by now what you're saying, and this one I suggested last time, and I was advising people, because you people like now you are the last, from the first person who presented is over a month, we anticipated to see an improvement. And one of the improvement I was saying is on the slide on what do you call it? Work plan. The work plan that you are showing here, this is the one that should do the proposal. This is not detailed. This was like a master work plan. But now when you start working out for the progress, we want to see for the objective one, what have you attained? By looking at the test that you have done, by the discussion that you have provided, we want to see what is the progress in objective one? What is the progress in objective two? What is remaining? Yeah, so that we can even be able to say objective one, 80% complete. And when you look at that, we see there were 10 tests, you have done 8 tests, and you have discussed them. It becomes outright 80% work done. But when you keep on putting this kind of all the way back in the proposal, right? Yeah, so think about that. I was expecting far much improvement from your work compared to the people who presented the previous, because I hope that you also, and the people who are listening here, and also those who are listening on YouTube, I believe you are correcting from the purpose of your attendance, and even for somebody not in this course, but he's doing research or anticipating to do research in the future. I believe the purpose why we are sharing this is that they gather something from this research, even if they're not going to conduct work related to this, but in their work, there shall be an improvement. That's what we call knowledge dissemination, right? Okay. So we need to see more in the methodology. We need to see the layout. We need to see the experimental plan. We need to see that experimental plan is the one I'm calling the test matrix. We need to see the details of your experiment, details of your experiment. The BRC mesh that you are using, we need to know the details. Now you have not even told us what type of BRC. Is it A198? Is it A98? Is it A142? Why the choice? Why did you choose that? Okay. See, what is the spacing between the spacing of the meshes? All those details need to be seen. Otherwise, now it's like you're giving us just a short summary, but I feel like you are giving us too much of the introduction, too much all the way. Maybe you have almost how many slides in the introduction before you come to methodology? Where does methodology start? Slide 12. Slide 12. You will not have enough time to present that. Like you could have one slide, background information, another slide, problem statement, another slide, objectives. And then if you want to have a limitation, it's okay. So those are already this 4 or 5 slides. 5 slides for the background information, 2 slides for literature. But don't get me wrong, the number of slides might not have a big issue. But for your work, I'm comparing in relation to the other slides that are more important. Because you can have a slide, but you just speak for like 10 seconds. Maybe you really need to show a figure in the introduction, and you don't speak too much on it. No problem with that. But I'm looking at, you have a total of 24 slides, but we are removing 12 of them is on the background information. And then the result you start discussing from which slide?
17.
Okay, 17. So what I'm saying is, now we are not so much in the proposal. Not even so much. We are not in proposal stage. So in as much as it's important for people to always know what is the problem, what is your gap, what is the problem. But this is the time now to see the result. Okay. So include those details that I have mentioned: schematic representation, test setup, test matrix, details of your columns. That will be in the test matrix, but you can also in the sketch, the details of the mesh, and then the testing. Okay, that will be the setup, the testing of your column. Then improve on the introduction so that people can really understand what inclusion of the BRC mesh is going to do to your work. And that will only come up once you read more on those papers. Okay.
Yeah.
And the result, the main result, I said for today it's okay. You showed us details about the material test, but I will suggest once you have more results on the columns and your structure, your column system, you can give just a summative like a tabulation, summative form of the material characteristic. Okay. Yeah. Like for the fine aggregate, you have shown us what is the moisture content, what is the, this can be done in a table and in one slide. All of them, moisture content, the specific gravity, what is the finest modulus, what is the aggregate crashing value. Yeah, like you have summarized in a table. Because this is just a material characterization. Yeah. Then you have the results when it starts showing us the results for the columns. Okay.
Okay.
So I can say your work is far much you're far much behind. You really need to speed up, to pull up your socks so that we can be able to start seeing results. So that once we start seeing the results, we can start interrogating them. Yeah, questioning whether why this thread. Remember, result experiment is not a straight. It's not a smooth curve or a smooth path the way we show in the presentations. When you start doing your experiment, things might not always end up going right. So you might find like you have to do some repetition or some confirmatory test. And that's why you need to have more time. You need to start your testing as early as now. Once you have sorted out the issue of the experimental procedures, so that in case you need to do another casting, which was not anticipated, you have a time allowance. Okay.
Okay. We had a small an issue. These uPVC tubes are quite costly, so having a lot of them to test is a bit challenging for us. So I don't know what you'd suggest we do concerning that.
No. What's the cost of one pipe?
The pipes, we had to go to Eslon Plastics and
why are you going there? Yeah, you are the one who if you go to the industry, because these are not unique pipes. What you just need to do, you have to be consistent. During my master's, yes, I started by going to Nairobi, but then I realized the people who are selling in the hardwares, in the local hardwares in Juja, they get them from Nairobi. So what you do, you need to buy them at one time, because you see, if you go to and now we have big hardwares around, not like Kitambo when you used to have very small hardwares. So that today you could go and get just one pipe of this type remaining, another one of different characteristics or different manufacturer. But now you can go to a slightly bigger hardware, buy them at the same time, so that you buy them from the same manufacturer and preferably maybe from the same batch. Okay. This pipe, I do not believe should be expensive, but you start incurring the issue of transportation, then it will become expensive. And again, I'm not saying that you're going to talk about, you see, like now, by the way, before I forget, you see, like now you're talking of sieve sizes used to 10, 5 minutes. You see, you have given the details of the sieve sizes, but our work is not so much into this. We need also to see the sizes of the columns. That's what I'm saying, talking about their details, important details which are lacking. Okay, so about that cost, I believe you can cut your cost by sourcing them locally. And number two, how many columns are we talking about now? And what is the length of that column? Because to me, I believe I'm looking at one pipe, usually the length, the bigger diameter, I believe they cut it at, is it 6 feet? Do they talk in feet or meters?
It's like 20 feet, 6 meters.
Oh, 6 meters, yeah, 6 meters. That is the one, the diameter is bigger. But if you have a small diameter, then the length is small. And I believe you're also varying. Are you varying the diameters?
Yeah.
Your work then seems to be too limited. What are you going to discuss? Yeah. The diameters, variation in height.
Yeah.
Yeah. You're varying the height,
Yeah.
We need to see those details. That's why I'm not able to ask many questions in your work, because we are not seeing those details. We don't see the standardization. I'm not saying that you have to vary the diameter, both of them. If you fix the diameter, then you vary the height, of course, the L/D ratio will vary. Because you want to see the variation for different, those are what you call the variables, the parameters, which are varying. And they help you discuss your work. Like you have a discussion of the effect of variation in height on the length of the column, on maybe the irrigation capacity or the ductility. Otherwise, if you just if now you might make your work to be simple the way you are thinking, but now when you come to discuss, you don't have anything to discuss. Because if I just give you one column, let's say one column with an aspect ratio of 2, the diameter of 100 and the height of 200, and then you test it, and then you don't even have you don't use the LVDTs, you don't have the load irrigation data. What are you going to discuss? What result are you going to show us? Yeah. So think about that, because we need to. This result about the material testing this is not too much. It's not very significant in your work. So you might not spend much time during the final presentation presenting this. And that's why sometimes people during the master's defense, when they go to the BPS, Board of Postgraduate Studies, after all the presentation, they show a lot of work, and then somebody says that this work does not meet the threshold for an MSc. So you might also start asking, does this work meet the threshold for a bachelor's course? Because your work is not, during your coursework, you did the laboratory experiment. How is this work different from the SIGO module that you did for a laboratory test? Like you went in the lab, you did the compressive strength test. You did the tensile, the split tensile test. You did the friction, right? But now we are bringing all those tests, and then we are moving ahead to see the behavior of our structural element. In that way, we'll be able to know that you can be able to gather together the knowledge that you have attained about laboratory procedures, about conducting a test, about designing a project and executing it. Okay, so there is a threshold also that we are looking for a bachelor's course, and that's why I'm saying if you discuss too much about the course and fine aggregate, this is for somebody who is dealing with like partial replacement of cement. They are doing materials, but your work. In fact, do you know your work? We anticipate at the end of this, we should have some interaction equations. We should have some empirical equations, whether new or whether you are going to just see what what the Mariam suggested. Their equation of I don't know which and what parameters you are going to vary, but you need to go to that level that you are showing a kind of a level of leadership. Yeah, in your work. Remember, by the time you are graduating, the statement that the VC says is that I've given you power to read. You know, you are becoming a scholar. And that's why you find like in this research, it comes in your final year of study. Because now you already been trained, you've gathered the theoretical knowledge. Now you're going to the practical field, to do your practical, to practice what you have learned. And one of the things that you'll be doing as an engineer is to handle project, to formulate, identify problem, suggest a solution, execute it, and oversee. This is what you're doing now. So there is the threshold, there's the level that we expect from you. That's why you don't see like I'm pushing you to just bring us more results, but I want you to bring more results, because by the time you are bringing more results or concerning columns, it also helps us, because it helps the reader to understand the work that you're doing and also appreciate the work that you're doing. If you just have a very strong title, and then when you come here, you just find that these are results for aggregates that you have discussed. And somebody will just say he had, we call them clickbait titles. The one you see in Ghetto magazines, a very shouting title, but when you start reading the article, there is nothing. Yeah. So think about that. Think about that. Think about what you really want to stand out. Assume like I remember where I was employed. Immediately I finished college. There was a guy who came to our lab, to that office. It was a structural design office in Westlands. And he was from University of Nairobi, and he had done a design of 45 meters high communication tower. And the engineer was so impressed. Actually, he brought a copy and kept it in the office. And when we were looking at I was looking at, there are many reasons that make people employable. But I was trying to imagine if the engineer was so excited, even to us, we could see that he was excited by that research. It means when he was employing him, he was moved also by that thing. So what we are saying is that if you have such a catchy title and a very promising one, and imagine when you go to employment and then you ask, what project did you do in your final year of study? Then you present this. Then you tell them the title and say, oh, I would like to read it. Would you be confident to take your bound copy to them? Because you know the title is catchy, but inside is just a bare minimum of material testing. Okay? So it also brings about the integrity in your work. So about the pipes, think about that. I'm not pushing you to spend from your pocket way beyond the budget that the university allows. But again, think about that option I've told you of sourcing locally, and also looking at, you don't have to have many specimens, but have different varieties, different types, like even sizes, length, and all that. Okay?
Yeah.
All right. So any other question?
No, we are fine.
Okay, question from the other members. I can see Mohammed, you joined us. Mohammed, you are the first one who presented.
Yes, Dr.
So I'm hoping that there is a far much improvement in your work.
Yes, we have finished most of the data collection, so we are just in the process of analyzing them.
Okay.
Yes.
Then, because today is the final, there's a final group.
Okay.
What do you think? Should we go back to the cycle? We start again?
Maybe there are some other group members who may wish to.
No, not
present.
today, next week. I'm talking from next week. I want to know the procedure from next week.
Yes. Maybe we can discuss with other members.
Okay.
Because we might have some people who are already done.
Okay.
And they would wish to present their work earlier. So maybe we'll talk it out in the group.
Or then have a schedule.
Yes, we'll have a schedule afterwards.
Okay.
Yes.
Then there is these guys. There were these people who are doing, I don't know where they are here. The group which was doing reinforcement by using plastic material and sand. Are they together with us? That is that should be who? Mark Maina and Irogo Dennis. Are you listening for, even if you are in the YouTube, you can say yes, you are around, you can hear us. Okay, because I wanted to see whether you have been able to prepare that specimen. Okay, now, the other person now to present is Paul Karoga and Raymond Washira. They are here. Paul Karoga, I can see you are connecting now, dear. So Keith, you can make Paul Karoga the presenter, the host. You know how?
Not really. How do I go about it?
Just go to, you can see them. You can see the name Paul Karoga. I don't know who is presenting between the two, but you can see Paul Karoga, is it?
Yes, I've done it. I've made him the host.
Okay, okay. So Paul, you are the host. Now you can share your work. Yeah, Dennis, I can see you saying you are able. Could you send me your methodology part? I want to see that material, that specimen that you have prepared. If you can prepare some methodology, that's just a small summary of the methodology so that you can be able to see that, then you send it to my email. I'll be glad. Paul, we are waiting for you. Paul.
Yes, Dr.
Yeah, you are the one who is presenting, or it's your colleague?
Yes, I'm around.
You've been made the host. What you need to do is you need to share the screen. At the bottom there, you can see the icon share screen.
Hello.
At the bottom there, at the bottom of your screen, you're on Zoom. So at the bottom there, you can see share screen.
Okay.
Paul, can you hear me? Can somebody talk to him, because I don't know what's happening to him. He have just disappeared, and I'm seeing like he's the only one who have connected for that group. Where is the other guy? Where is Raymond Washira? I wanted us to end this thing by 9:40 because you have another meeting at 10. Raymond Washira and Paul Karoga, we were waiting for you, but you have disappeared. Okay. All right. Do we have anybody else, even in this on YouTube? The one who are following, I can see on YouTube there are 8 people who are following. One of them, I believe, is Dennis. Anyone with a question? Raymond, you're saying you are going to join. So we are waiting for you. Can you join and then you be the host? We are waiting for you, and anybody else who have a question can chat there.
Hello, Daktari, can you hear me?
Sorry, I was on a call.
Okay, okay.
So you've been made the host. You are the host still, eh? Oh no. Okay, you are the host now.
Okay, yeah, I'm the host now.
So you can share your screen, and then we'll move very fast because we do not have enough time.
Okay. So can everyone see my screen?
Yes, we can. You can start. But I think it's good you make it in presentation mode.
Yes, that's what I'm trying to do. Does it come?
Yes. Now go ahead.
Can everyone see my screen?
Yes,
Yeah.
you can. You can proceed. Start. Go ahead. Presentation mode.
Yes. Okay. Our project is our comparative analysis of autogenous and autonomous self-filling concrete, presented by Mwangi Raymond Mashira, who is my project partner, and myself, Mori Paul Karuga, being supervised by Dr. Naftali Gadhiba. Here are our contents, and we start with the background study. And as you all know, crack forms in concrete due to the limited tensile strength of concrete, which makes it vulnerable to cracks. Where now through the cracks, liquids and gases can enter, which can deteriorate the mechanical properties of the structure. Now in self-healing, now due to this, self-healing has now received a tremendous attention due to its advanced automatic crack detection and compared to the standard concrete. And there are two main types of self-healing mechanisms, which is autogenous and autonomous. In autogenous, this is where healing of cracks occurs due to rehydration of unhydrated cement particles. And as you can see in the photo, this is how it occurs, where a crack is formed, water seeps in through the crack, a carbonation process occurs and seals the crack. In autonomous, this is where a bacteria is used as a self-healing agent for healing the cracks. And as you can see in the photo also, a crack is formed, water seeps in through, reacts with the bacteria inside the concrete, and due to the reaction, it seals the crack. For problem statements, currently, self-healing concrete is not being implemented in the local construction industry, which leaves structures susceptible to cracking, which can lead to steel reinforcement corrosion, increased overall cost due to maintenance, reduction of overall strength, loss of aesthetic value, and in severe cases of collapses of building. Our main objective was to perform comparison analysis between autonomous and autogenous self-filling concrete. Specific objective, we wanted to compare compressive strength, tensile strength, and its workability on both concretes to determine which self-filling concrete is most efficient and can be best applied in the local construction industry, and to determine the rate of crack healing in both types of concrete and factors affecting them. For such justification, self-filling concrete increases the durability of overall structure, which helps retain its aesthetic appearance, reduce maintenance of cost and repair works. Scope and limitation. So a scope involved sourcing the bacteria from microbiology labs, sourcing of calcium nitrate for the autonomous concrete, the fly ash for autogenous, preparation of the concrete cubes and cylinders for the tests for both compression and tensile, and performing the strength tests on both types of self-healing concrete. Limitation: we were only sourcing one type of bacteria from a wide variety of species. We lacked a lyophilizer machine, which is a machine used to convert bacteria to powder, which can be put in capsules, we could have used for more comparison analysis in our autonomous concretes. Time as healing of crack in autogenous concrete due to the fly ash, it's seen clearly after 56 days. Also, a lack of scanning electron microscope, which is a machine which used to measure the crack closure ratio. Literature review. If you'll allow me, I'll just pick one. For the first one, which was done by Bathena, which is a novel approach for increasing its durability in bacterial concrete. The compressive strength of cement matrix was taken after 3 and 7 days of curing, was noted to have increased. Okay, I'll do one here also by Naveen and Siva Kamasundari. Study on the effect of calcite precipitating bacterial self-healing mechanism of concrete, where the efficiency of the biological treatment was assessed by means of uPVC, uPV, and visual measurements, which it was found to be highly desirable and pollution-free and natural.
Can kindly take over from here. I'll do the research gap. The researchers didn't take into consideration the cost for sourcing the bacteria, as the bacteria used in the experiment was extracted from the labs, and it will be costly to use that lab extracted bacteria, plus also the source of the nutrient of the bacteria, which we had to purchase for ourselves. The researchers did not consider a source of nutrient for the bacteria, as it needs nutrients to survive in the concrete, because it can't just survive on itself. It has to feed on something, because it's just like any other living organism. The researchers didn't relate the age of the concrete in relation to the crack width healed. For our methodology, we started by sourcing materials, which were mainly for the bacterial side, the autonomous was the bacteria, and the calcium nitrate, which acted as a nutrient for the bacteria, and also sourcing the fly ash, the aggregates, and the bags of cement and sand, which were required. So that before preparing those samples, we had to conduct a trial mix, perform a sieve analysis and a consistency test. We had to prepare the bacterial broth, which took some time in the microbiology lab, and we had to prepare the formwork and the steel work for the beams which we were to cast. For the autonomous concrete bacteria, the concentration ratio was 13 liters per meter cubed. And the calcium nitrate, which is the nutrient for the bacteria, was 2.5% of the weight of the cement. The concrete mix ratio applied of cement, sand to coarse was 1:1:2. For the autogenous concrete, which involves fly ash, we divided it into two samples, one which had 10% of the weight of cement, and another which had 20% of the weight of cement. So for testing, we conducted, on fresh concrete, we conducted the slump test, and we have our results. And now for the hardened concrete, we are currently conducting compressive strength tests, split tensile strength tests, and 3-point bending tests at 7 days, 14 days, and 28 days. These are our results for the slump test. We did for the control, for the autonomous and autogenous. And after 7 days, we also did a compressive strength test for the cubes. The results are there, 32 for the control, autonomous, and the 10% fly ash and 20% fly ash. And for the cylinders, we also conducted the split tensile strength test after 7 days. These are the control, autonomous, and autogenous. This is our work plan and reference. Thank you.
You've done some work, but again, the result you have shown us, but you have not explained anything about them. Hmm? You have shown us result on the slump. You have shown us the result on the is it on the tensile?
Yes. And
Yes, tensile and
compressive.
Compressive, but you have not said nothing about them. Like, so what about them now?
Oh, yes. After 7 days, the autogenous is stronger out of all the three. It's stronger than the autonomous, the one with the bacteria. Both
But you
the
never said
10%
anything.
and
You never said anything during presentation.
Yeah,
Always explain your results.
yeah. So we observed
Give an
after
explanation. And there are two levels
Yeah.
of explaining.
Yes.
One is stating, showing us the thread, showing us what is happening,
Yes.
which everybody can see. But anyway, you have to say like at 7 days, it's increasing. Number two is a scientific explanation. What is causing that increase? What is happening?
Yes.
And this one you explain, basing your argument on the test that you have done, the results that you have obtained, maybe from the preceding test, like material test. Once the first objective, you're doing the material test and all that. By the time you come to talking of concrete, you will explain the issue of the concrete by first referring to the behavior of the bacteria, what it's doing. At the same time, maybe you might even use the materials that you used. Maybe they have this characteristic that we are able to get this strength. Otherwise, if you do this, the result, if you give us result, like move backward. Can you move backward? Again? You see? Yeah, here. Material test. So if you're talking of, you did like the slump test, right?
Yes.
Yes.
Okay. Can you move backward? That's right. Again. Next, back again. Okay, we are starting the other one. Forward.
Yeah.
What I'm saying is, in the methodology where you start, the material sourcing and the material preparation and the test that you do, the preliminary test or the very fast test that you do, help you to describe the behavior that you're going to obtain from your result, maybe the ultimate result. So you don't just show us the thread. That's one thing. And even in this case, you did not tell us the thread, just the thread, the observation. What is the thread? That was lacking. Number two, the scientific explanation. What is happening? Okay.
Yes.
That's going to be very, very clear. And number two, in discussing your results,
Yes.
like move to the slump test. It becomes difficult to see this slide, and then the next slide is still on slump test, is it? Slide 19.
No, it's on compression.
Okay, slide 19, and then the next slide is
On tensile.
Tensile.
Oh, okay. But I don't know how you feel about it.
Yes. For the autobacterial, the autonomous, it's the calcium, the subtilis reacts with the calcium nitrate to form crystals of calcium carbonate. And this formation, this calcium carbonate is what will help in the closure of the crack. Sorry, we didn't include it in the, we didn't explain it well enough.
Okay, so make sure, just be careful about that. Then the same case on the other slides, especially the introduction, I was just seeing some unexplained photos flying by. Like a photo or a figure just comes, don't say anything about it, then you go to the next slide. Is that true?
Yes.
Yeah, so anything that you show us, remember this is a presentation. Anything you show us, it should have a significance, a meaning. Yeah. So you don't have to spend much time on it, but you need to mention, like can you move to slide number in the introduction? I believe it's either the first slide of introduction or the second one. Next. Next. I believe there's somewhere I show a graph. I mean, I was seeing some Clark photo of cracks and nothing. This one. So we didn't understand, like, what is it that you want to talk about in this one? And I'm not saying it's only in this one, but even in other photos, you need to tell us, like, just make it like a normal conversation, normal discussion. It's a presentation. Like you're saying, there's a problem statement can be seen in this graph, blah, 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 in this photo, this and this is happening, and therefore, all that. Make it part of your discussion, because I believe you're using it to enrich your presentation. So
Yes.
let it play its role. Then I wanted to understand.
Yes.
On the objective, specific objective number 1, you're seeing you're talking about the workability.
Yes.
And I'm wondering, does inclusion of these bacteria, or how do you anticipate them to affect the workability? As measured by slump, like what is causing, if you move to the result, now I'm seeing like here talking about workability, because I'm trying to understand.
Yes.
If you move to the result on slump, can you move to the result on slump? I believe there is a change.
Yes.
The control have got 39.
39, autonomous 42, and autogenous with 10, 59, and 20%, 36.
So how do you explain between the control and the autonomous? The cause of increase in the slump?
The autogenous was more stable.
No, remember slump.
10%. Yeah.
Remember at the slump stage, this is fresh concrete. The issue of crack healing are not coming into play. We are talking about fresh concrete. So any reaction, biological or whatsoever, have not occurred in autonomous, is it?
Yes, the
Because
bacteria still have
autonomous
not
is one that
reacted.
have got bacteria.
Yes.
I'm wondering,
it still hasn't. The bacteria at this time is still has still not reacted to form the calcium carbonate.
The formation of calcium carbonate, that will come into play, because calcium carbonate, we are talking about being cementitious material, formation of that cementitious compound. That is in hardened concrete. But here I want to understand what causes, how can you explain the increase from 39 to 42 of the slump from control?
Now in autonomous, there's a reduced water content, because now we have to include the bacteria. So water is a bit reduced. So that's the reason causing the difference.
The reduction in water. Let me take it the way you have stated it. Before I come back to that. Then if there is a reduction in water, then why is there an increase in slump? And while you are at it there, I want to understand, aren't you maintaining the water cement ratio? Isn't it constant? Is it a variable?
No, it's still 1:1:2.
Then why, the first question would be, why do you say that the water content will reduce? Does it mean these bacteria are drinking the water? I mean, I just want to understand. This is what we call explaining your results. Why is this? Yes, we can see the trend. I am not saying it's wrong because you found this result in the lab. I mean, you did the test and you found this. By the way, this result, how many specimens are you doing the average?
Pardon?
This value 42 millimeters.
Yes.
Is it just for one specimen, or are you doing an average of a number of specimens?
We did 2.
I don't agree with 2. Usually minimum 3. Of course, if you do proper research, we talk of sample sizing, but in our lab, our instructors or engineers try to be a little bit lazy, so we go with a minimum of 3. Do you know why we do 3? Let's assume you do 1, and then there is an error in measurement, and you see the difference between the control. Maybe the difference is very small. Maybe the difference was supposed to be insignificant. Assume you have one have got 42, the other one have got 40, the other one have got 38, the third one. You see the average is, I'm talking about one being 42, the other one being maybe that 7, the other one being 40.5, something like that. You do the average, you get the autonomous is 39.5, which is an insignificant difference.
Yeah.
But if you do 2, you are not quite sure again. 3 is a bare minimum because 2, 1 could be erroneous. So which one is correct? So if you do a test, let's say like the concrete crashing, let's even stick with the slump. You know the slump, there's a way you lift the cone, and if by mistake you are not vertical enough, you are not maintaining verticality, the tilt itself is supposed to have a forced slump. You cause the slump to be erroneous. So if one result gives you a slump of 60, another one gives a slump of 39. If you just have 2 specimens, you're just going to average those 2 and get over 50. You get something like 50 something. But maybe one was 60, the other one will be 39, the other one will be 41. You will question yourself, this 60, is it correct? That's the purpose or the need why we, or the reason why we need to have at least a bare minimum of 3 tests.
Yeah.
But my question is not answered here. Somebody will want to know what is causing this change in slump. And even before we go to the other cases whereby you're using the fry ash, somebody will just want to know what is happening to the, because it's just fresh concrete, you have just added bacteria. And what is the dosage, by the way?
13 liters per meter cubed.
Now, the question somebody will try to understand, you were wondering at the back of the mind, that quantity of bacteria that you have added, minute things, why do we have the change in the slump? What explanation can I give? And that's what we call discussing the results.
Yeah.
And you can only discuss this if you read. You read other people's work, you read books, you read the journals, magazine, and all this. You see, because I found somewhere, I have found students, sometimes they do an error in the methodology. There is an error in the methodology, but they think it's the trend. Yeah. Like there was somebody who was saying, like now, if you just do a mistake of varying the water cement ratio, you have introduced another variable. So you'll not be able to explain what changes, what causes a change in slump. Because if you add more water, extra water, the slump will increase. But if you hold water cement ratio constant, then we need to understand why. So interrogate your results. And not only this one, even on the compressive strength test, which now they are explainable, but that explanation is the one that we are saying it was still lacking. But every result that you present, people need to understand what is causing that. Number two, it's always very good at this stage. Once you are from proposal stage, you are done with doing that. From result, when you come to the progress and even the final presentation, methodology becomes key, and the result and discussion section, and even conclusion section. So that don't just rush in the result section, but you talked so much about what you are going to do. In the introduction section, you showed us the gap, you showed us the challenges that or the shortcomings that were with the previous research. But when we come to the results, it's a very, very small part, very, 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 sketchy result, and again, and detailed work, and that's the meat of your work. Like now I'm looking at, I was trying to see at the methodology, because in the specific, in the limitation, if you can go back to the limitation, you are talking of the limitation, one of the limitation being that the second last, time as healing of crack in autogenous concrete is clearly seen after 56 days. And then I'm wondering if you already know that you're only going to get the beneficial effect of this autogenous concrete after these 56 days, right? Then
Yes.
why are you putting it here at a limitation? It's just about planning, because you have in a semester, you have how many days? These are 16 weeks. Let's even remove the 2 weeks for the exam. You have 14 weeks. 14 times, how many days are those? 14 times, even multiply by 6, by 5. They are beyond this, is it? So I'm wondering, it's like you're telling us this is a limitation. Limitation is somewhere that you're not able to achieve. Okay? It's a level that you are not going to achieve. Sure. But if you're not going to get to 56 days, that's when the issue, the aspect of the fire should be able to be achieved, or we are able to get the beneficial effect of using that, the fire and all that. Then why? What's the purpose of your need?
No, there'll still be progress in the autogenous concrete. The crack will still heal. The crack will still reduce in width, but not as efficiently, as clearly.
It won't heal to the full extent that of its potential. But there will still be a considerable difference.
In that case, then your research, you are talking of the comparison as a comparative study. How it's like being unfair. It's like being unfair. Being unfair, like what? Let give you an example of what. You have not allowed it to get to its full potential. So I'm wondering, how are you going to compare between the two methods, the autogenous and the autonomous, the methods that you are suggesting? You get my point. You have not allowed it to mature, and then you are saying you are going to compare. So to me, I think.
But maybe we were thinking maybe now in. Okay, now we are thinking now when we're explaining this now in the conclusion section, maybe we will explain in the way that for autogenous concrete, it will take longer for it to achieve the crack closure compared now to the autonomous, which autonomous takes a shorter time.
Yes, but if, this is what I'm saying, if you are going to get up to 56 days, is that true?
Yes.
Are you going to do the test after 56 days for autogenous concrete?
Yes.
Yes.
Then it's not a limitation. I thought you are not going to do that. I thought that you are saying that you are putting it here to say you are not going to get to that number of days. But if you are going to get up to that number of days, then it's no longer a limitation. You understand my point?
Yes.
Oh.
Yeah. Okay. Then another thing, in the research gap, if you can go to the research gap, yeah, could you move the slide on the research gap? Can you hear me? Yes? These guys are lost again. But maybe they can listen later on because this video is always there.
Yes.
Another thing in the research gap, you mentioned about the cost. Yeah, you are talking about, actually your research gap was very strong because the research gap shows something that was not done by other people, and that's where now you are coming to bring your contribution. So you've given, in your research, you've talked about the cost, They did not do the cost. I wish I could be able to read again that statement. But there you had 3 statements in the research gap, and one of them was on the cost. The other
Yes.
one was on what? The other one was on
Well, the source of the nutrient for the bacteria.
yeah, the
the-
nutrients.
And the relating of the age of the concrete in relation to
Relating the age. Yeah.
Yeah.
So you see, then if it's a gap, that's your strong point. Then we need to see it in the methodology. We need to see it in the result that actually now your work captures those gaps, or it
Yes.
attempts. It attempts, because again, as always, I always tell you that research is a continuous process, and I'm not saying that you're going to get to the end of this, but at least you are attempting to address some of those shortcomings that we are there with the other researchers, is it?
Yeah. Yes.
So that being said, I believe we can comfortably say that your work, and maybe for both of the 2 groups that you presented today, there is a lot of reading that is required from literature. First, so that you can be able to explain your result, as well as you can be able to explain to have your the problem that you are trying to address, making people understand. Is it?
Yes.
You get me?
Yeah. We will work on it.
Yeah. And also, you also need to move with speed.
Yes.
You need to move with speed. I don't know whether we have. I want to stop there because of the other engagement that I'm having. But I also want to know whether there's somebody with a question. If it's a question that you can be able to answer here concerning either this presentation or an issue that you have seen from today's presentation that you believe might be affecting your research, or maybe a challenge that you might have been encountering in your work, and you want us to help you in one way or the other. You can raise it here. I can see a number of you have come to Zoom. It's okay. You can join using any. And just about 5 minutes I can give to any one of you now. Okay, first of all, let's start with you, Raymond, and Paul.
Yes.
Any question you have on your work?
Yes. Okay, I had a question on, because one of the tests we said we were going to do was a 3-point bending. But the point of the 3-point bending was not to test the flexural strength. It was just to initiate the crack. Now we're wondering how we'll fit it in, how we'll say it. Yes, in the project. In the project.
But who suggested you do that? You suggested yourself?
Yes. Because due to now time factor, we thought maybe we can try and initiate the crack right now on beams and see how it behaves with the 3-point bending machine.
By the way, you've casted your beams?
Yes, we casted them last week on Thursday.
And there is a lot of information you are hiding, because all that we need to see those can I call them schematic presentations, layout of the experimental work. We need to see. It's important that we see so that we can the workflow. Yeah, yes. Don't wait until, and especially those what I'm calling the schematic representation. Okay. Yeah. So it's very, very important that we see that. But you're saying, you see, to me, my thinking is,
yes,
you are introducing a crack, then you want to cause it to heal.
Yes.
After the healing occurs, are you going to conduct the test to see performance of that the concrete member?
Okay, now after healing, we are just going to test the size of the crack, the width of the crack. Because the point of that was just to measure how the rate of the crack closure on both concretes and a control but there's no need for control on both concrete.
I don't have an issue with that. It can stop there, but we need to be more interesting and more beneficial to an engineer who would wish to know that after the crack have healed, how is the performance of my concrete? Wouldn't it be more beneficial? Even if not necessarily for the doing the test, but I'm just asking you because, I mean, for somebody in chemistry, maybe he's more interested in the performance or in this what do you call it? There's a course, biochemistry.
Yes.
They might be interested in, maybe they want to initiate a new type, they want to investigate on the bacteria performance. So for them, they might be just interested in the crack closure, which one performs better, which bacteria is preferable. But for us, I'm asking, what our interest in this bacteria? Is that the crack heals? But then in the future, we want to know after the crack heals, how is the performance? And this performance should be in the, maybe like what is the ultimate capacity. But I'll leave it at that. Because I was thinking, you have a test from the control, which is the one that doesn't have any treatment.
Yes.
And then the one that you introduce the crack, then the crack causes the healing. I mean, then the bacteria causes the healing in the crack.
Yes.
Then we test so that we see what is maybe even the ultimate load capacity. That would have been my thinking.
Okay, noted, sir. Thank you.
Yeah, but about the crack, it's something that was very interesting because I told you there's some a master student in Pau who is doing similar work, and the question that was coming up was on the issue of initiation of crack.
Yes.
They were talking of a micro crack. And the question was how to ensure that the crack that will be initiated, like how to ensure the geometry, like the length, the gap.
Yeah.
Because they were suggesting of using a sharp. They were initially suggesting using a nail, and somebody was saying that would be very large of a crack. Then they say they use a very fine, sharp incision object to make an incision, and it was a debate. It was a serious debate because even there was a professor from biochemistry who was there, and it was an interesting discussion. And that's why I'm saying, for your work as you present to us, you might take that direction of the biochemistry and all that, but the audience that you are presenting to, and also the degree that you are holding, well, interdisciplinary research is very much encouraged. But again, we also want to see, in terms of structural engineering, what benefit are you attaining? You might not need to go to those levels, but just think about it and then decide whether it's good for your research or not.
Okay, thank you, sir. Okay.
All right. Who else before we close? Because it's just 4 minutes to the other meeting. Okay. All right. Let's stop it for today. And if you have any query on your research, I believe there was a group that you are supposed to agree on ratios, but I hope they agreed on the mixed ratios. They already sorted on that out. But it's always good as you progress. You do not have necessarily to wait until the next presentation. If you have something that you feel like you need some guide on, you can always talk. That's why we opened up that WhatsApp group there. You might even have a question which can be answered by another of your colleagues. Maybe like you're having challenge in the experimental lab, and then they tell you this is how we approached it. Then you can do ABCD. So that's why the purpose of that WhatsApp group. For those who are not in the group, of course, those not in the class, that's the reason why we have the videos on YouTube I'm sharing there. If you have any question concerning research work, you can always leave your comment there. All right, thank you for coming today, and thank you. I hope that our discussion, our seminars are helping you and other people to improve on their research. So allow me to end there, and until next time, continue working on your work, continue improving. I believe the presentation will be announced in a very short while. maybe not more than 2 weeks to come. So be on the lookout and also continue preparing. So bye-bye.
Thank you.